In this video, we're going to look at the idea of outliers in a bivariate relationship, and specifically look at the idea of leverage and influence. So leverage points and influence points. Any point that is considered an outlier has the potential to influence our regression model. So in general, we would call a point an outlier if it strays far enough away from the trend of the other values. So you could have an observation that is an outlier in the x direction, so that would mean a value that has an unusually large x value. You could have an outlier in the y direction, so it has an unusually large y value, or you could even have an outlier in both x and y. So that would be a point that doesn't fit the trend of the data because it extends way beyond the usual values for x and y. So here's a particularly interesting case, and this was something that was discussed a lot more when I was in school than when you're in school. But this is looking at a couple of candidates during the 2000 presidential election. Now, in the 2000 presidential election, a lot of people are used to hearing people talk about George Bush and Al Gore. But what they don't realize is there were some other people running for president at the same time. So here is an example that involves Ralph Nader and Pat Buchanan. So the blue points at the bottom look at different counties in Florida, and as you can see, there's a pretty strong positive linear relationship between the votes won by Nader when we compare them to the votes won by Buchanan, except for one unusual point, and that unusual point is this red X near the top of the scatter plot. Something different happened in Palm Beach County, Florida. Now, I've been saying since the beginning of the year, when you encounter an outlier, chances are that outlier has a story, and this outlier is no different. In this particular case, Palm Beach County was the county where we encountered what was called the butterfly ballot, and this is where you start hearing about things like the hanging chads. Interestingly enough, what happened was people thought they were voting for one candidate, but actually they were voting for another candidate, and that's where we see this interesting outlier. What's really interesting is what would happen if we remove that outlier. So including this point, we see the red regression line. If we remove that point, we see the blue regression line. So it actually changes the relationship between votes won for Nader and votes won for Buchanan. Any linear model with large residuals will not fit particularly well. And one of the problems we have with this is it actually changes occasionally the slope or the intercept of the regression line. In some cases, it can even change our r and our r squared value. So it's really important that we pay attention to these points. We would say that a point has leverage if it has an x value that's far from the other x values. And what a leverage point has the potential to do is actually change the regression equation. What's important to note is, though, a leverage point doesn't always change the linear relationship. If a point does give us a different model, like it did in the Buchanan versus Nader example, we would say that that point is influential, so it influenced the model. A lot of times statisticians will examine these points, and if appropriate, they'll remove them to get a better linear model. Remember, our whole goal of regression modeling is our ability to make predictions, and a value that influences the model may have the ability to make our predictions a little less accurate. So here's two examples. This is IQ versus shoe size. So in general, when you look at those blue points, we don't really have much of a linear relationship at all. They probably have an R value very close to 0. So as shoe size increases, IQ remains constant. And we would hope that that would happen because intelligence quotient is not supposed to change over our lifetime, but obviously shoe size will change as we grow. So in the graph on the left, if we put that unusually large value with a very high IQ, it creates a positive linear model. On the other hand, if that point had a very low IQ, it would actually change the relationship to have a negative slope. So these influential points can have a really big impact on our regression models, so they should not be ignored. When we investigate this unusual point, it'll sometimes tell us something about what is going on in the data. Like I said, every outlier has a story, but just be cautious about just actually deleting those points. We're not always allowed to do that. If it kind of feels like outliers, leverage points, and influential points are all talking about the same thing, it's because they are. Um, Influential points and leverage points are both examples of outliers, but they're unique instances. So an influential point is a point that actually changes the model. A leverage point is a point that has the potential to change the model. So again, in this case, all influential points are leverage points, but not all leverage points are influential points. The important thing to realize is these are outliers, and if the outliers changes our model, then that's something that we need to pay very close attention to. In the next video on this page, you'll see an actual example where we're going to look at historical data on cigarette consumption per capita, and then the instances of lung cancer from, I think, the 1930s. And it's another pretty good example of what happens when we remove a data point and how it changes the relationship in the regression line.